Welcome to this presentation on concurrency and parallelism in programming languages. Today we will explore the concept of concurrency, threads, processes, and how different programming languages implement these principles. Let's dive in. Concurrency refers to the ability of a program to manage multiple tasks at the same time, even though they might not be executed simultaneously. The key benefit of concurrency is resource management. For example, handling multiple file downloads concurrently increases efficiency and responsiveness in applications. Let's start with the distinction between threads and processes. A thread is the smallest unit of execution within a process. Threads within the same process share memory space and resources. In Java, we can create a thread using the thread class and start it with the start method. On the other hand, a process is an independent unit of execution with its own memory space. In C++, we can create a process using the fork function. Unlike threads, processes do not share memory, making them more isolated but heavier on system resources. So, what's the key difference between threads and processes? Threads share memory and resources, which allows for faster context switching. Processes, however, have their own independent memory space, making them more resource intensive. Threads are ideal for lightweight tasks, while processes are best suited for tasks that require isolation. Java supports concurrency through its built-in multithreading capabilities. The thread class and the runnable interface allow us to create threads. We can override the run method in the thread class to define the task and then start the thread with the class method. Java also provides thread synchronization mechanisms, ensuring that shared resources are accessed safely. The synchronize keyword helps to prevent race conditions, ensuring only one thread accesses a resource at a time. In Go, concurrency is built into the language using Go routines. A Go routine is a lightweight thread managed by the Go runtime. Go routines are created using the Go keyword and they can be executed concurrently with other tasks. Go also uses channels for synchronization and communication between coroutines. Channels allow Go routines to send and receive data safely, making it easier to coordinate and synchronize concurrent tasks. Synchronization ensures that multiple threads or processes access shared resources without conflicts. This can be done using mechanisms like locks. In Python, for example, we can use the threading lock to ensure that only one thread modifies a resource at a time. Deadlock occurs when two or more threads or processes are waiting for each other to release resources, creating a standstill. This can be avoided through careful resource allocation strategies or using timeouts to prevent indefinite waiting. Parallelism refers to executing multiple tasks simultaneously, often used often using multiple processors or cores. This is particularly useful for computationally intense tasks as it reduces execution time by dividing the workload across multiple units. While concurrency involves logically managing multiple tasks, parallelism focuses on performing tasks simultaneously. Concurrency handles tasks in a way that might appear to be happening at the same time, but not necessarily. Parallelism, on the other hand, executes tasks at the same time on separate processors. In Python, we can implement concurrency using the asyncio library. This allows us to define tasks that can run concurrently by utilizing asynchronous programming. For example, we can run multiple tasks concurrently with the await keyword, managing their execution efficiently. To achieve parallelism in Python, we can use the multiprocessing library. This allows us to run tasks in parallel on different CPU cores, making it ideal for CPU-bound tasks. Each process runs independently with its own memory space, improving performance for heavy computations. To sum up, both concurrency and parallelism are crucial concepts for developing efficient applications. Concurrency helps in managing multiple tasks, while parallelism speeds up computationally heavy operations. Understanding these concepts and how they are implemented in different programming languages will help you optimize your code. That concludes the presentation on concurrency and parallelism. Thank you for your attention. If you have any questions or need further clarification, feel free to ask.